Hi, this is Dr. B. I would like to go over the topic significant figures uh, and prepare you for the first exam. So my objective today is to identify which digits are significant, to know which zero count and which zero do not count. Use the correct rule for multiplication and division. Use the correct rule for addition and subtraction. Be ready for mixed problems. The first rule, all non-zero digits are significant. The example we have here, 72.48 grams. Just we count how many digits we have. We have 1, 2, 3, 4. And we're going to say we have 4 sig fig. The second rule stated that zero between non-zero digits are significant. So we have 4.007. All these zeros are counted. So we have 1, 2, 3, 4 sig fig. So the first rule, all non-zeros are significant. Second rule, captive zeros. Third rule, zeros to the left to the first non-digit are not significant. So leading zeros are not significant. So we have all these zeros are not significant. So we have only two significant figures of this number. Okay, so leading zeros are not significant. The fourth rule, saying trailing zeros to the right to decimal point are significant. So we have here zeros at the end after decimal point, and has to be, there's a number here which is 9 and 3, at least one number. So these two zeros are significant. So the number of significant figures here, 1, 2, 3, 4. So they are 4, sorry, 4 sig fig. And I want to talk about these zeros. Assume that we have 9,300. So the trailing zeros for the whole numbers are not significant. So how many sig fig here? These two zeros are not counted, so we have only two sig fig. Now, if I want these two zeros to be counted, so as significant, just say now this is, now I have 4 sig fig. Okay, again, another way to do it. Now, if these two zeros are significant and I wanted these two zeros to be counted, I can add the decimal point at the end of the numbers. So these are 4 sig fig. Okay, this is a good one. So another slide emphasizing what I have just said. Trailing zeros in the whole number without decimal point are usually not counted. So we have here 4,200. We have only two sig fig. The two zeros in here are not counted. Again, 4,200. If I want these two zeros to be counted, I can add the decimal point and everything will be there. So it will be 4 sig fig. And actually, if you want to know how many sig fig using scientific notation, we're going to move the decimal point 1, 2, 3, 4.2, 10 to the power 3. This shows you how many sig fig. Here we have only 2 sig fig. This slide talking about the exact numbers. So the only thing that it is counted or limited, here saying limit significant figures in our calculations, only the measured numbers, not the counted numbers or not the converted numbers. Conversion factors or convergence are not counted, so this is not counted or limit the significant figures, or how many students, how many cars, how many hats. It is not counted or limited significant figures. Now this slide talks about how we're gonna do multiplication and division and applying this rule with the final answer and decide how many sig fig in our final answer. Here they say the final answer must have the same number of significant figures as the measurement with the fewest. This is the key word, the fewest or the lowest significant figure. The example that we have here, what is the final answer? With the correct significant figures, when we multiply 3.24 times 2.1. So the answer here will be, let me see here, 6.804. So the final answer 6.804. Now look here, we multiply 3 sig fig times 2 sig fig. The final answer has to be 2 sig fig. So the final answer will be 6.8. Now the next number, it is 0, which is less than 5, so we cannot round it up to 9. Now let's talk about addition and subtraction. The rule says here the final answer must be rounded to the same decimal places to the measurement with the fewest. Now we talk about the fewest. This is the keyword, decimal places. We are not talking about how many sig fig of the numbers added. Let us add them together. I like you to line them up. 12.36, and then you have 0.8, then you have 4.125, here 4. The final answer is 5, 8, 2, 7, and 1. Now here the rule says the fewest, and from what we see here is 0.8 is the fewest, so we have only one digit after the decimal point, so the final answer will include only one digit. However, when we delete 85, but because 8 is higher than 5, So we're going to round up. So the final answer will be 17.3. Okay. So let us now practice. How many significant figures are in 0.0040500? So the first three zeros are leading zeros, so they are not significant. And the rest of the zeros here, the captive zero in between and the trailing zeros are counted. So this is 1, 2, sorry, 1, 2, 3, 4, 5. So there are 5 sig fig. Okay. If I want to convert this to scientific notation, so let me move the zeros here. 1, 2, 3. So 4.0500 times minus 3. So how many sig fig do I have here? 1, 2, 3, 4, 5. Second problem. Calculate 6.204 times 0.5 and report the answer with correct significant figures. So 6.204 times 0.5 is 0, so equal 3.102. Okay, now we multiply here 4 sig fig with 2 sig fig. The final answer will have 2 sig fig, so the final answer will be 3.1. Let's go to the next problem. Calculate 18.75 plus 2.3 minus 0.456. So the answer is 20.594. Now, which one has the fewest number of sig fig? Clearly, we have only one digit after the decimal point, so we're going to end with 20 point. Now it's supposed to be 5, but here we have 9, higher than 5. We're going to round it up to 6. So this is the final answer, 20.6. Let's go to now problem number 4. A sample has a mass of 0.003480 gram and a volume of 2.0 10 to the power minus 3 liter. Calculate the density and report your answer in scientific notation with correct significant figures. Let's do the density here. Okay, so we need to calculate the density. Density is equal mass over volume, and the mass here we have is 0.003. So if I want to write it in scientific notation, I will go, oh, sorry, here, 1, 2, 3. So 3.480 times 10 to the power minus 3 gram over 2.0 10 to the power minus 3 liter. Here 0.3 and 0.3, these are going to cancel out. 10 to the power, and we're going to divide 3.480 over 2.0. This is equal 1.74 gram per liter. Now look here, we are multiplying 4 Sig Fig by 2 Sig Fig. The final answer had to be 2 Sig Fig, so the final answer will be 1.7 gram per liter. This is the final answer. We cannot round it up because here 4 less than 5. That's it, and good luck in your exam.